Okay, you are welcome back to Introductory Mathematical Analysis A. Introductory Mathematical Analysis A. And now we are in Chapter 8. Chapter 8. In Chapter 8. Okay, Chapter 8. The purpose of Chapter 8. Chapter 8 deals with probability. Okay, let's talk about that first. Probability. Okay, that is what Chapter 8 is all about. And we are going to be determining, or the purpose of this chapter is to determine a sample space, is to define what is meant by probability of an event, is to discuss conditional probability, is to develop the notion of independent events, and then to develop the Bayes formula. Okay, so that is what we are going to be covering in this chapter 8. Okay, so we are going to just jump into 8.3, 8.4, 8.5, 8.6, and 8.7. Okay. Now 8.3, we are going to be talking about sample spaces and event. Sample spaces and event. Okay, let's start with what is a sample space. A sample space S is a set of all possible outcomes. All possible outcomes. All possible outcomes. Okay, we can also say is a set of all possible options. Okay, so all the possible options that we have, that is what we call the sample space. And the number of the sample points is donated by this. So sometimes we have to find the number of the sample points. So anytime we have this hash with the sample space, then we are looking for the number. How many are the possible outcomes? Or how many are the possible options? So that is what we are going to be dealing with when we put this hash with that. Okay. Let's go to example 1. Two different coins are tossed and the result, head or tail, for each coin is observed. Determine a sample space. Determine all the possible outcomes or options. Okay, so we have a coin. You must first know that in a coin we have a head or a tail. Okay, that is in a coin, a head or a tail. Now we are tossing two different coins. Okay, two coins are being tossed. That means the first one could be a head, the second one could be a head also, or a tail. So that means this is the sample space now. This is for the first one, this is for the second one, this is for the first one, this is for the second one, this for the first one, this for the second one, this for the first one, this is for the second one. Okay, so we have the first coin, the second coin. So the first coin could be a head, the second coin could be a head. First coin a head, second coin a tail. Now we are done with the head for the first one. So we go to the tail of the first one. Tail first one, then head second one. Tail first one, then head second, tail second one. So we are just finding the possible options, the possible outcomes. All right, so in tossing two coins, these are the possible outcomes that could happen. Okay, someone may start with a head first before the other one. So what is the number of this sample point? If I put hashtag with S, I need to find the number. And what is the number now? The number is 4. Because this is 1, this is 2, okay, this is 3, and this is 4. Okay, this is 4. So the number of the sample point is 4. All right, make sure you understand how we got that. All right, so let's go again. Now, a bag contains 4 jelly beans, 1 red, 1 pink, 1 black, and 1 white. Okay, 1 red, 1 pink, 1 white, one red, 1 pink, 1 black, and 1 white. A jelly bean is withdrawn at random. Its color is noted and it is put back in the bag. It is put back. You see, that is with replacement. All right, so in probability, we are going to be talking about 2 things which we have to take note very strongly. Number 1, without replacement. And then number 2, with replacement. Okay, without replacement, when we say without replacement, anything that is taken is out of it. It affects the total, it affects the color that is being taken, okay? But with replacement, you bring it back, so your sample point is still the same, like that, okay? So a jelly bean is taken at random, its color is noted and it is put back in the bag. Then a jelly bean is again randomly withdrawn and its color noted. Describe a sample space and determine the number of sample points. Okay, let's describe this sample space. 1 red, we have 1 red, we have 1 pink, we have 1 black, and we have 1 white. Okay, so that is our bag. That is the bag. The bag contains this one. Okay, so a jelly bean is withdrawn at random and is color noted and is put back in the bag. Then another one is taken. So 2 jelly beans are taken. So I can take the first one, red. Now I want to describe my sample space now. I can take the first one, red, but because red is put back, okay, you can have another one, red. Okay, so it's because it is put back. If it is not put back, then we cannot have the second one to be red again because we only have one red. All right, that is 1 red and then pink. Okay. Then we have red and blue. Then we have red, white. Okay, red is finished at the first one now. So let's go to pink. Pink first, pink second. Pink first, red second. Pink first, blue. Pink W, okay, for the white. Then we are done with pink now as the first one. Then we'll go to blue, 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 red, blue, pink, blue, white. Okay, then we'll go to white now. White, red, white, pink, white, blue, of course, white, white. Okay. All right, so this is the sample space. If you count, how many sample points are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So the number of the sample point is 16. So you can see these are the sample because the first one is taken and the second one also, and with replacement. That's why we have this there. Okay. So that is why we have 16 for the sample point. This is called partial sample space because it is taken out of the sample space. You see, this red, white, pink, blue, red, blue, white, white is taken out of these ones. So that is why it is called partial sample space. Okay, but the sample space is given as this, and this is the number of the sample point. Okay. All right, now we want to determine the number of sample points in the sample space if the two jelly beans are selected in succession without replacement. Now, when we say without replacement, let's go back to what we did before. Without replacement, when we're talking about it, without replacement, we are not going to have this there. Because as soon as we take the red is gone. We can't have any red there again. Without replacement, this will not be there also. Without replacement, this will not be there. Without replacement, this will not be there. So if you count the number of the sample point without replacement, will now be 12. You see, will be 12 because we are doing without replacement now. All right, so without replacement, we are going to have the number to be 4 multiplied by 3, which is 12, or we have it in this form for permutation 2. Okay, in this permutation, we are going to introduce you to, let me quickly introduce you to this permutation thing. When we say n permutation r, we mean r factorial over n minus r factorial. Okay, n minus r factorial. All right, that is permutation. Okay, so now if I now say for permutation 2, I mean 4 factorial over 4 minus 2 factorial. Okay, that will be 4 factorial is 4 times 3 times 2 times 1. Okay, all over. This will be 2 factorial. That means 2 factorial, which is same thing as 2 times 1. Okay, so this and this cancel. Then we're going to have 4 multiplied by 3, which is 12. Okay, so combination has to do with arrangement, and you can write it this way for combination 2, or you write it this way for permutation rather 2, or for permutation 2. You write for permutation 2, or you write for permutation 2. You can write this way. Also, you can write it this way. This way. You can write it this way. You can write it this way, n permutation r, or you write it this way, n permutation r. Okay, that is permutation. We are also going to come in contact with combination. This is combination. When you see the C there, that is combination. And that formula is given as this. That formula is given as this. Okay, that is the formula for combination. You can also write this way, n combination r. Okay, so that is for combination. Okay, please take note of that. We're going to come into it later also. All right, so let's move. So when we talk about an event, okay, when we talk about event, an event E is a subset of sample space, is a subset of the sample space for the experiment. So when we say an event E is a subset of the sample space for the experiment. So when we have a sample space like the one we have before, let me call this a sample space. Let me call this a sample space. Then an event could be the odd of this one. So 1, 3, 5. Okay. This is a subset of this. This is taken from this. So it's a subset of this. All this is contained in this one. Okay, this one contains everything here. So that is an event. Okay. Now let's now see. Let's take this example. A pair of die is rolled once, and for each die, the number that turns up is observed. Determine the number of sample points. Okay, we want to find the number of sample points. A pair of dice, that means 2 die. 2 die. So when we say a pair of dice, we mean 2 die. One die has these possible outcomes, 1, 2, 3, 4, 5, 6. That is one die. The second die also have these possible outcomes. The same thing, 1, 2, 3, 4, 5, 6. All right, so if you want to find the sample point or the sample space, let's find the sample space first, then you understand why we get this as the sample point. In the sample space, if I throw this first one, I can get 1. Throwing the second one, 1 also. Okay. First one, 1, second one, 2. So in order for you to find the sample space, you need to go in an orderly manner so that you don't miss out anything. Okay. So you see, I can have 1, 3. I can have 1, 4. I can have 1, 5. I can have 1, 6. So I finish with the first one now. Then I can go to the second one, and then I have 2, 1. I have 2, 2. Then I have 2, 3. So I'm starting with 2 now. So I have 2, 4, and like that. If I continue that pattern, I will discover that the whole of this thing, if I count it, then it will be 36. So that's why the number of the sample point is 36. The number of the sample point is 36. And that is because the first die has 6 possible outcomes or 6 possible ways. And then the second one also 6. So the first one is 6. The second one is 6. If you multiply the two together, then you get 36. Okay. You can also write them out like this. If they ask you to write out the sample space, then you write them out like this, and then you count it, then you also get 36. All right. Okay, so let's take this example. Given the usual sample space, x equals to this, for the rolling of a die, let E, F, and G be the event. So we have this E given as an event, 1, 3, 5. We have F given as this, and then we have G given as this. Now we want to determine the complement of E. The complement of E is everything in E, everything that is not in E but is in the sample space. Okay, everything that is not in E but is in the sample space. What is that one? 2, 4, and 6. So we see 1, 3, and 5 is in E. 2, 4, and 6 is not in E, so we pick that one. All right, so when we want to find E union F, what is E? This is E, this is F. So you pick everything in both of them, but you don't repeat it. So 3 is there, 3 is there. You don't need to write 3 2 times, just write it once. So we have 1, 3, 4, 5, and 6. Okay, that is the union of E and F. All right. Now if you want to find the intercept of E and F is everything that is common to both of them, and that is 3 and 5. That is 3 and 5. Okay, sometimes there is no intercept. So for example, the intersection of F and G, there's nothing to there's no intercept in them. So that is an empty space. We write it like this, 0 with a cross. That is empty set. Is an empty set. So whenever we don't have an intercept, so we have an empty set there. All right. Please make sure you take note. And you can see that if we have E union the E-intercept, E union E-intercept will give us the sample space. And E-intercept E-complement will give us empty because there's nothing between them. So E-intercept E-complement will give us empty. But E union E complement will give us the sample space itself. Okay. All right, you can go through this property of an event, which tells us a lot of other properties that we have in an event E, an event F, concerning intercept, union, or intercept, or complement. Please ensure that you go through that. Please make sure you understand